Okay, Bismillahirrahmanirrahim. My name is Amirul Hafiz bin Abdul Muin. My matrix number is 2022861346, and today we are going to talk about application of differentiation related rate. Okay, so related rate is a calculus concept that deals with finding the rate of change of one variable with respect to another variable. In related rate problem, you are given the rate of change of one variable and asked to find the rate of change of another variable that is related to it. For example, if you know the rate at which the radius of a circle is changing, you can use a related rate to find the rate at which its area is changing. This type of problem require you to use the chain rule and implicit differentiation to find the derivative of the related variable with respect to time. Okay, so next after this, why we use related rate? We use related rate in calculus to solve problems that involve the rate of change of two or more related variables. Related rates are used to find the rate of change of one variable with respect to another variable, such as time. This can be useful in many real-world scenarios, such as calculating the rate at which the level in a tank is changing, or the rate at which the distance between two moving objects is changing. By using relative rates, we can find the rate of change of one variable in terms of the rate of change of another variable, and solve problems that would otherwise be difficult or impossible to solve. Related rate also help us to better understanding the relationship between the different variables and how they change over time.
Calculus 1, Chapter 3, Application of Differentiation Subtopic Rate of Change. We have the equation is made and put into a conical pipe at the rate of 10 meter cube per minute. Most bottom radius is already half the height. How fast will the area of the base be increasing when the pipe is 8 cm high? The volume for conical pipe is 1/3 pi r square h. The first we find the information from the equation. We have the rate of 10 meter per cube per minute. As we know, the rate is equal to opacity. And the second point is water radius is always half the height. And the second point is increasing when the pipe is 8 higher. When they say increasing, it must positive. If he say the decreasing, it must negative. The best way to find this solution is circle, circle, square, circle is to circle times circle. First circle is what given in the equation, and second point is what we want to find, and the third circle is when the information given, and this square is for formula, and the circle is for additional info. And the last circle is for solution. The given from the equation is rate of 10 meter per cube per minute. Means is dV over dt equals to 10. And we want to find the area, and what we want to find is dA over dt equals to something. And when is 8 cm. The formula is V equals to 1/3 pi square h, and the additional info is water radius is always half the highest, and we know the R equals to h over 2, and we can divide it to the h equals to R, and the formula for area is A pi R square. When we differentiate this, we can get dA over dr equals to 2 pi r, and then we submit the h into this formula, we can get the 1/3 pi r square h to r, and we convert and we get the answer is 2/3 pi r squared. And when we differentiate this, we can get the dv over dr. And the answer is 2 pi r squared. And then the solution I will give to the z. Next part is solution. Solution, as you know, we want to find dA over dt. How to find dA over dt is by divide by something and something by dA d over something and something over dt. What we should to substitute in this something, we back to additional information, and we get is the given information. The given is dv, and we substitute to this dv and dv over something. After we get dA over dt equal to dv over dt times dA over dv, we substitute the given information to these two circles. What the given is dv over dt is equal to 10. We substitute 10 to this. The next is dA over dv. dA, as we know, dA over dv equals to dA dv. What we should write at this part is from the additional information. What is dA over dr? We put this. These two must equal. As we know, dr over dr equal to 1. Okay, we substitute these two terms from the given. As we know, dA over dr equal to 2 pi r. 2 pi r times dr over dv at this 2 pi r. As we know, 2 pi r equal to 1, and we upside down, we will get the 1 over 2 pi r squared. dA over dv we can get 1 over r with this. So we get this 1 over r, we substitute this to this 1 over r. The final solution is dA over dt. The final solution is dA over dt equal to 10 times 1 over r. As we know, dA over dt equal to 10 over r. Lastly, dA over dt equal to 10 over r. How to find r? Back to question. Radius is always half the height, so h over 2. We write that r radius equal to h over 2. And next is additional from the additional information is h equal to 8. So we write h equal to 8. We substitute this to this. So r equal to 8 over 2. So r equal to 4. Next we substitute this r equal to 4 into the 10 over r. So dA over dt equal to 10 over 4, and we'll get 5 over 2. From the solution dA we will get dA over dt equal to 5 over 2 meter cube per minute. This is the final answer. A small change in our life can make our future be better.
The conclusion is that we can identify every rate of change of something will change the quantity in a certain mass. The rate of change also helps us identify how much volume can be loaded and can be reduced to avoid